The first lecture on Chapter 4 deals with variables, and what we're going to do in Chapter 4 with these variables is we're going to draw pictures. We're going to display this data, and looking at the picture, we're going to try to decipher or determine some things that are happening within that data set. So we have two types of variables or data that we're going to collect. We have qualitative and quantitative. And just as the word qualitative sounds like, it's going to be a quality. Where quantitative sounds like a quantity. And we talk about a quantity, we're talking about a number. Qualitative data can be numerical. However, it's what we consider to be categorical. So again, it can be a number. However, the data cannot have a mathematical operation that has meaning. So no mathematical operation has meaning. So let's look at some examples of categorical or qualitative data. It might be a phone number. Just as we said, it's a number, but if I was to take two phone numbers and add them up, try to find an average, there's no meaning behind that average. But notice it is a category. When I say 406, I'm categorizing you into the state of Montana. Male, female. Those are categories. They're qualities, either you're male or you're female. Your Social Security number is, again, a categorical data. It tells you when you or what state you received your Social Security number in. However, adding Social Security numbers and averaging them has no meaning. When we look at quantitative, that's our numerical data. Mathematical operations work. We apply mathematical operations. And one that we'll be using a lot is finding what we call the average. Underneath quantitative, we have two types. We have discrete and we have continuous. Discrete is a finite number, where continuous is not a finite number. And when we say a finite number, we mean that it's countable. So an example of this would be the number of students enrolled. It might be number of credits. It's countable. When I have continuous, what happens in continuous, I can take on any value in between. So it can take on any value in between. So if we look at a number line, 1 and 2 are countable, but this number line is continuous. I can take on any one of these single values, and there are infinitely number of values between 1 and 2. A great way to remember the difference between these is that continuous versus discrete. Continuous is a measure. When I measure distance, sure, I can record it in feet, I could record it in inches, and so forth. There's a smaller and smaller measurement that I can get more and more precise when I weigh something. So measurement and weight, anytime you use those, you're looking at continuous data. Another kind of gray area with this continuous data would be age. Age truly is continuous, because we could measure age down to the smallest millisecond and keep going smaller and smaller in terms of the measurement we take. However, age, when we report it, is discrete. We report age as discrete. I am so many years old. We don't say I'm so many years old, months, days, minutes, seconds, and so forth. So that's the difference between continuous and discrete. But notice both of these are quantitative variables, where anytime it's a quality or most likely a name, it's going to be qualitative. So let's take a look at some practice. 14 campus vending machines. 14 is discrete. We also know it is quantitative because it's a number. 3 students were absent. Again, discrete. The car took 147.3 feet to stop. Notice we didn't continue with the measurement, but that is a continuous measurement. We could have refined that decimal and continued on. And the radar found the car was traveling 92.3 miles per hour. Again, continuous. So what we're going to be doing here with these displays as we take these types of variables is we're going to start looking at the distribution of those, and that's what's coming in the next lecture.